All right, hello everyone. Welcome to the first live session of this NPTEL course, Software Conceptual Design. Uh, all right, so I'm Prajish and Lakshmi is also here with me to answer your doubts and queries for this session. Professor Sridhar could not join. Hopefully, for the upcoming sessions, he should be there. Yeah. So, Yeah. So so I see that there are around, 10 to 11 people watching. Okay. So in the chat, you can suggest about anything which you want to share regarding week one, and week two has also been released, I think a couple of days back. So if you have any doubts or anything else which you want to share regarding the course, you can share right now. Okay, someone is saying my voice is very low. Lakshmi, is my voice very low? Should I increase the volume?
I'm able to hear you. Uh,
Okay, okay. Okay, okay, fine, fine. All right. Yeah, let's just wait for a few minutes. Okay, Vinayak is asking, sir, will you offer internship? Okay, so uh, I think that is an NPTEL policy about who to offer internship and who not to. So I believe they have some criteria about which students should be offered internship and so on. So I would suggest that you go through their website and contact them and see if options are available. So as such, through this course, we are not in a position to offer internships to anyone. Yeah, thanks, Vinayak, for that question. Okay, Lakshmi, as people are just joining in, would you like to take some answer questions from the form which we received? Like we had got one
sure.
question regarding the requirements, right?
Yeah. So there was this question about the star requirement analysis method, or otherwise known as the star model. And there was a question about what is the star model and requirements. So I'll just start with giving an expansion of what is star. It's a specification, trade-off, and analysis of the requirement. Now, generally, what happens now, let me just take you through the context before I explain the jargon. Let me just take you through the context. What generally happens is requirements are often imprecise and they are vague, and it can so happen the requirements can be contradictory to one another. Okay, for example, okay, let's take the mood based music player. One of the requirement that they say is it should have a extremely secure authentication mechanism, right? Which means that a person would need to give multiple would need to be authorized in multiple different ways, which we generally see these days now. Also, you get an OTP, you are required to write the password and all that. But at the same time, there is another requirement which says that as and when the mode is detected, the songs need to start playing in exactly 2 seconds. Okay. So now these could be contradictory requirements, right? Which says that it needs to be extremely secure and multiple authentication, and then this requirement that the songs need to start playing in 2 seconds. So what does the star actually do is, it kind of gives us a heuristics for understanding how requirements are interacting with one another. Are there any conflicting relationship between the requirements? And then once they're identified that there are conflicting requirements, there is a systematic approach, and how to give priority to certain things, how to move the priority of certain things, and so on and so forth. So basically, what STAR model helps you understand is the relationship between the requirements and to find out if there are any contradictory requirements. Now, in week two, we have been seeing think and link, and we have also been trying to kind of look at function behavior structure. And in the same thing, when you see there also we are trying to evaluate the correctness of the FPS graph. Are there any contradictory statements there? So, in a way, we are actually trying to see that in the FPS graph also. So, this is the star model, and maybe what we will do is after the end of this live session, we will put on some links for more reading on the star model. And in a way, when you if you do the FPS graph and do all the activities in think and link, you would be doing this process of analyzing contradictory requirements and contradictory statements. So, yeah, that's all, Prajish, from my end on that question.
Yeah, thanks, Lakshmi. Thanks. All right. Okay, yeah, Vinayak. Yeah, so Vinayak, just to follow up, yeah, so they will about for your question regarding, yeah, so I think Bharti is replying to that. Yeah, so I think once the results and all come, uh, we can see how to take it forward. Yeah, thanks, Bharti, for answering that. All right. Okay, those who are there in the chat, I can see around 19 people. Uh, so how has week one and two been till now? Any thoughts, any suggestions about how it was? Anything which you would like to share? All right. Uh, yeah. So if there isn't anything specific, what we'll do is I have a set of slides. Uh, we'll just go through that. I'll just share my screen. All right. Lakshmi, just want to confirm if you can see my screen.
Yeah, I can see your screen, Prajish. It's fine.
Okay, okay. All right. So we have been learners who are watching this on YouTube, what you can do is go to this website www.menti.com, right? And you can type in this code 43751931, right? 43751931, and yeah, and you can answer this question. So you have gone through week one. I'm sure you all have gone through the videos, and I see many people engaging in the forum. So this question about, what is the most interesting thing you have learned about this, about software in general, that you were not aware of before? All right, I don't think anyone has um, joined the Menti link. Yeah, just want to check if it is accessible. Let me just check.
Yeah,
Is
I'm
there
able to
any?
access it, Prajish. It's working.
Okay, okay, all right. Okay, so learners who are watching this on YouTube, what you can do is go to menti.com on your mobile or your browser anywhere, and yeah, use this code 43751931, and maybe just to get your feedback on what is the most interesting thing you have learned about software. Okay, I'm just checking out the comments if there are anything.
Kavya, you can answer using the Menti link. Kavya Ravindran, Ravichandran rather.
All right. Okay, good. So, yeah, so someone is saying software development methodology, like waterfall, agile. Okay, all right. Okay, any other responses? Anything from the chat? Okay, nothing as of now. Yeah, so okay, another response is software is made of many individual components. All right. Okay, anything else? Yeah, Lakshmi, do you want to maybe add onto any of these points about the different methodologies and this this point about software being made of individual components? Do you want to talk about that?
Yeah, so that's these are the major points that we saw in week one is how to look at software as a combination of different components, and we gave some examples of those components. One was a payment gateway, the other one was about how does one of the component like wallet works. So the other aspects about what are the methodologies comes in when we want to talk about what are the different processes that we use to create software, or what is the flow of processes. So in waterfall we kind of see that it's very linear, and one ends and then the other one starts, and that's when you get the model of a waterfall. And in agile it's very iterative, and those were the some important aspects that we looked at when we were talking about the processes. So one is what is software made up of, and how the second one deals with what are the different processes and the flow of processes while creating a software. Yeah, so well done, the two people who have written and captured the week one um, important takeaways.
Right, right, right. So yeah, I just want to maybe ask you also because you have also worked in the software industry and all these concepts look very nice on paper, right? Like this waterfall model or the agile methodology of all these different phases in software development. But in real life, is it actually the case? Does it, very neatly follow one after the other, or or how does it work actually?
Yeah, that's a good question. So, yeah, in real life, it doesn't really work the way that's it's on the paper. So these are just structures, right? How do we want to work with? And these structures need not be followed to the T. It's just completely dependent on what does a team feel comfortable, and they can adapt or adopt these structures in terms like waterfall or agile to create their own processes that on the structure of the processes that works for them as well as the client, the timelines and all that. So I think I agree with you to say that this it's something that it's good to know that these structures exist, because only when we know that these structures exist we can adapt and adopt them to our own software development teams. So Prajish, since you also been working, what has been your experience in this? Yeah, so if you can also share your experience.
Yeah. So yeah, that's what you said is right, because why you need to know these terms is, once you start working in the industry, you will encounter these teams of, there will be people who are, their main job role is to do testing, right? And there are different types of testing. And then there are designers who will come up with the UI, the UX, and and before that itself, there is the product design team who will think of or will gather requirements and all of this. So all of these are there in a typical software company, but once you start working, you will soon realize that there's a lot of communication, lot of back and forth between the product design team and the stakeholders, the clients, and many a times midway between coding, you will soon realize that the requirements have changed. The client likes something else or they want something different. Then again, the design team comes up with something, and then you have to, change it on the fly. So, uh, in that way, this development process is, very uh, iterative, sometimes very chaotic, right? Especially when you work with large teams, of different people, and it's a very big project, lot of requirements and lot of dependencies, right? And yeah, so the important thing to remember is that, yeah, as Lakshmi said, as you join the software industry, if you're working in a small team of a startup, let's say a startup or something, their process will be very much different compared to, if you are working maybe for the software in a bank, or maybe, some uh, large organizations where their processes are fairly fixed and routine. So, but the important thing to keep in mind is that some form or other of these processes are there. And through this course, we just wanted to make you all aware that these terms or these processes exist, right? So that wherever you join and whatever you do in the software industry, you'll be aware of these concepts. All right. Okay. So the second point about software is made up of many individual components, right? Uh, we had sorry, we had some activities also for you to start thinking about different components for a software. We had something known as an LXI, and yeah, many people have started posting things uh, uh, in the forums. That is good to see. So, if you have noticed, unlike a traditional course where there are primarily videos, uh, in this course, there are different components of this course, right? So there are lectures, of course, but in between lectures, you have things known as LXIs, or learner experience interactions, where we post a focus question, and then you can post your responses in the discussion forum. All right. So one of them was about uh, an LXI about posting two components of, choose a software amongst these and post two components about them, right? And many of you have responded to it. That is good. Yeah, I would encourage the others also who are taking the course to go through these, go through what your peers have written, start thinking about it, and reply to your peers as well, right? So that is one component. Then we have something known as an LXT, which is extra resources for a particular topic which you can read about, right? And for LXIs and LXTs, there are things known as quizzes, which are not graded, but it is there for you to, quickly do a self-assessment of how or what you have learned, right? So that's all. Okay, so yeah, so I hope all of you will engage more deeply with the course and especially in these LXTs and LXIs. Okay, so moving on to this point about components, right? So one of the questions was in the LXI was to post about two components for a particular website, right, or a software. And yeah, I just looked at the responses, and for the IRCTC website, uh, this is some of the components which you all have posted about, right? The train booking management system, train tracking system, meals management, payment management. Yeah. So this idea that software has all of these different components, but when we use it, it all seems like a big and a nice shiny product which, works most of the time, right? And as software designers, you would also have to think about, what are these different components? How are they interacting with each other? And what are its functionalities and all of that. So, yeah, I hope through the LXIs you would try to understand, take a software and try to deconstruct it and see what are the different parts to it. Uh, yeah. So, Lakshmi, do you want to say something more about these different components? Because in week two, uh, we are looking a little more into detail in detail on how to think about these different components, right?
Yeah, thank you. The idea about components is like in week one, we kind of, want to start thinking how a software is made up of, different individually working components which work together to achieve the whole software. So in week two, we go a little deeper to kind of say that, what do we mean by when we say components? Um, are we referring to the behavior of the system as a component, or are we referring to, let's say, an algorithm as a component, or some sort of a hardware piece as a component? Week two, we go deeper into this, and also when we look at certain aspects, why we are kind of harping about to think about these components is we see that in certain cases some of them are there across all the different kinds of software, right? For example, in many of the software that the kind of meal tracking or a booking, the first thing that you would want to get into is a customer identification kind of a component, which requires them to have a profile name, an email, and their login ID and their password. So this is common across, right? And if you kind of want to, let's say, keep a history, user history, that's also common across. So the idea is to say that, certain components can be reused, and it's not like you have to develop everything from the scratch. These days, with no code platforms and also with so many libraries present, it is finding the finding the right library and using it in your software to develop. So that is the reason why we want you to start thinking in terms of components, so that you know that certain things are common across the different kinds of software. And the aspect of reusability, code reusability, is what we want you to think about. Yeah, Prajish, if you want to add something.
No, no, thanks, Lakshmi. No, nothing much to add. Yeah, good, good. So, yeah, in week 2, 3, and all, we will take you through one process whereby you can, which will help you think about these different components and how do you go about detailing out, detailing it out, uh, and fleshing it out in much more detail. So, in week 2 and 3, you will learn that. All right. And yeah, maybe I'll just take one more point, which was the second LXI which we had regarding, yeah, so this was the second LXI which we had, right? Of how is software building similar or different from building a car, right? And even for this, many of you have posted in the forums. It's good to see that. I would encourage those who haven't yet to uh, visit the forum, check your peers' responses, and try to comment on that, or try to add some new points of your own as well, right? And I've just collated some of the differences which you all said. So yeah, so some of these are, yeah, it was there in our discussions as well, right? Where software is dynamic and abstract, but in case of building a car, it is static and you have certain fixed modules, right? Physical modules which are tangible, right? And some of the points which came out was regarding, the failure of a car, versus the failure of software. So which is more dangerous? Is the failure of a car more dangerous than software? And regarding maintenance, right? If uh, it seems that it is easier to do a maintenance of software uh, than a car. Yes, so these are some points which you all spoke about in the forum. Uh, yeah, Lakshmi, do you want to add or maybe comment on any of these points?
Yeah, so thanks, Pradesh. So I want to, like, very well done. I mean, maintenance and failure and, modifications are something that we haven't handled in week 1, but I'm glad to see that our participants are thinking in those lines. Um, also, the aspect about a car having fixed physical modules, wherein in software we deal with something that is intangible, in the sense that you can't touch, feel some of the components. It's just there, lying there. Those components are there, and you will have to utilize them. So that makes it all the more complex. So that's the reason why in week 2 we kind of give you some kind of a visualization in which you can bring in those components and link those components to see. um, Also, let's say, the idea about failure and maintenance, though it might seem easy, in a software, it's actually not quite easy, because software has built in a lot more complexity. The timeline from wherein you create the software to somebody else maintaining it, that's why the whole documentation is very important, because someone would have created something with something in mind, and when you change, when you are not the creator and you are maintaining the code, a small change in the code could lead to a lot of erratic behavior. So though it may seem easy, yeah, and also, I mean, where is the software? Which place the software is placed? Okay, if you think that the software is in a real-time application, like a aircraft system, then the failure is fatal, right? But if you can still think of a failure on a game, on a mobile, the failure is still okay. So it's where the software is going to be placed makes a whole lot of difference in failure handling and all those things. So though it might seem straightforward, but it's actually not quite. And yeah.
Yeah. Thanks, Lakshmi. Yeah, those are really good points, about, and there are so many instances of uh, uh, failures in software which have led to catastrophes, which have led to loss of lives. Um, yeah, in a way, it reminds us, how powerful software is, and especially in today's times, where a lot of things are being run by software. And so, how we have to be even more careful when we design software systems. That's so important. Yeah, and even regarding maintenance, so the flip side is that software being so abstract and intangible, we really don't know where the errors are occurring and how it's working out. So all that adds to the maintenance and to the delays and all of those things also. So yeah, those are good important points.
And
Okay,
we
I'll
have
just
one more person joining in and talking about failure. Fabiha Magdumi is talking about how software in the financial side failures can be catastrophe. Yeah, that's why you have many components there, like you have a payment gateway, which kind of ensures that the transactions are atomic and the transactions are secure. And you have secure authentication mechanisms to ensure that you're the right person who logs in. So I agree. That's a good also example by Fahiba.
yeah. Thanks for being here. Thanks. Yeah. All right. I don't see any other questions or any other doubts in the chat. Lakshmi, do you want to add anything? Maybe something about week two, anything
Yeah,
important which you want to say?
yeah. I want to talk about week two. See, week two gives you a perspective to think with. Okay, so when you are at the conceptual design phase of software, when things are so abstract and intangible, you would need, let's say, some perspective or some kind of a tool that you can think with, how to design. You might get stuck while you're designing. You might just be thinking about one particular, aspect or one particular feature, whereas you will have to design the whole software keeping in mind. So the idea the FPS design framework is to give you perspective to think with and also kind of a tool which you could utilize. And the Think in Link learning environment helps you uh, to bring in this process of thinking, right? So it gives you an example. It slowly takes you through first just looking at the FPS graph and then editing the FPS graph and creating something for your own problem. So I would encourage everyone to utilize the learning environment, and make use of this particular week. Yeah.
All right. I think we don't have any other questions or queries, and I think it's a good note to on a good. Yeah, I think it's time to end the session. Bharti, is there anything which is required? Uh, can we end the session? All right, learners. So All the best for the upcoming weeks. Please use the forums and go through the other activities along with the lectures as you go through the course, and hope we all have a good time. All right.
Yeah, happy learning and thank you all for your participation. Yeah, I can see some thank yous. If you have any questions, please let us know and we can take them up. I mean, we can see thank yous on the chat.
All right.
So can we close the?
Yeah. Yeah, I think we can close. Bharti, if you're there, you can close the live streaming. Okay, Lakshmi, we have one question from Sabiha, who's asking, in this course, will we learn implementation of OOPS principles to create modular software? Yeah, would you like to talk
Sorry,
about that?
one second. Um,
Yeah, in this course, will we learn implementation of OOPS principles to create modular software?
yeah. So, okay. So I'll take this thing. There are two things here in the question if we kind of look closely. Thank you for the question, first of all. One is the object-oriented principles, and the other one is modular software, right? So object-oriented principles goes very specific, though we wouldn't want to take up anything that is very specific in terms of creating a software design. We are still talking, let's say, how to even start with, even to reach the place wherein you will create something which is very specific as object oriented principles, and utilizing them, how to even get started to getting started to create, software conceptual design. That's where we are, and that's the aim of the course. And if you look closely, yes, modularity is an important aspect and a principle in the course that we kind of specify. And even in week one, we have specified why it's important to have modularity in your software. We also kind of take you through how to create such modular software and how to test for such modular software in the upcoming weeks. But no, we will not be taking very specific form of design, which is object oriented programming concepts. That's my answer, Prajish. Yeah.
Okay, thanks, Lakshmi. Thanks. Yeah. Yeah, Fabia, yeah. Thank you for the question. So, yeah, specifically for this course, our aim is to give a very gentle introduction about software design. And this course shouldn't be considered like uh, the the fundamental course in software design or OOPS principles and all of that. But broadly, we will be talking about different aspects of software design. And I think with this information and whatever you learn in this course, then I would encourage you to go through a software engineering course which takes you in detail into each of these concepts, right? So in that way, this course will give you a broad overview of the different aspects in software design, but we won't be going into specifics of uh, especially the OOPS principle. Yeah. Okay, hope we could answer your question, Fabia. Okay. Okay, I think there aren't any other questions. So yeah, I think we can end the session.
Yeah.
Okay, Bharti, are you there in the call? Uh, yeah, I think you can end the session.
Sure. No, we can wait for a couple of minutes to see if we are getting any more questions, and then we can, Prajish, we can do that. No? Yeah.
Yeah, yeah, we can wait for 2 minutes. Yeah,
Yeah.
that's Okay, we have one question from Kaveya. She's asking about, yeah, does this course give a basic learning to become a software developer in the future? Yeah, Lakshmi, do you want to take that question?
Yeah, thanks, Prajish. Yeah, so this is, see, many, let's say, software engineering books would talk about the different tools that are there, your UML modeling tools. They would in depth go into the different processes that are there, the methodologies like um, the waterfall methodology, the agile methodology. So they would they would in depth go into those, but the idea of this course is to give a starter on some of the practices that are there, okay, in the discipline of software engineering. Now, the two important practices that we want to we want the learners to take away from this course is the ability to be able to think in terms of function, behavior, and structure, and kind of link them. That is what you will do in week 2. And also the ability to be able to model and evaluate that particular model and test the model, right? So these are some important disciplinary practices that are there in software engineering. Many expert software engineers do it, and it's recommended that any novice also starts beginning to do this. So this is like a 101 or a starter to, let's say, some of the disciplinary practices in software engineering, specifically in software conceptual design, and that's where this course comes from. And um, and this is what we want the learner to be able to take away. Yeah, Prajish, you want to add?
Yeah, thanks, Lakshmi. No, I don't have anything else to add. Yeah. So, uh, so your specific question was about software development, right? And of course, if you want to go into software development, you need proficiency in a particular programming language. That is one thing. Uh, and usually, what happens is you start working in a software development team. You work for a few years, you gain experience, and then uh, you know, uh, are promoted to higher roles and higher positions, right? But I think the principles which you learn in this course, as you develop your software, maybe you might be a student and you are going to do something in your final year, right? And some of these principles, like what Lakshmi said about uh, thinking about different components, linking them together, all those things will help you uh, as you develop software, maybe as a student, or maybe as you go into the industry and you start working on projects, right? So in that way, yes, definitely, I believe that these things or these practices which you learn uh, will will definitely help you become a better software developer. So in that way, yes. But of course, there are many other skills which are needed to become a good software developer, right? So coding or understanding the basic concepts, that's important. Design is one aspect of it, right? Then there is communication, working in a team. So many things are there, right? And in week 4, we'll look at some of those aspects. Uh, yeah. So I hope we could answer that question. Yes, it will. I think if you apply these practices and you apply it consistently, I believe you'll definitely become a better software.
Yeah, another key thing, and I think adding to Prajish and what Prajish ended with, the key, I think, is also about a lot of practice, repeated practice. Yeah, and in this course, we have designed the assignments for you to be able to apply whatever you're learning as a practice. And if you kind of do those practices and repeated practices over the time will get you to become a good software designer and be one of the best software designer, because these are all certain things that experts do. They learn something, they keep on practicing. And like Prajish said, there are other things like you would have to pick up a programming language, become proficient in it, and then kind of be able to work in a team, those things that Prajish mentioned, and the practice that you keep doing every day. I think that will help you become a good programmer and one of the best, maybe.
All right. Prajwal is asking about a lecture on game programming. So game programming is, unfortunately, it's not a part of this course. I'm sure in NPTEL or in other uh, videos, even in YouTube, I think you will get detailed information about that. Yeah, but we won't be looking at game programming specifically in this course. But I'm sure the principles which you learned here, you can apply it for when you design games as well. Okay, I don't see any more questions. So shall we end this session? Yeah, anything is okay from us, from our side. And,
Because we wait for another 2 minutes again, because we see that when we wait, there are some questions coming up.
yeah, yeah, sure,
Sure, sure. We'll wait.
sure, sure, definitely. Yeah. Yes, sure, sure. Yeah.
Okay.